Hello, everyone, and thank you for joining Rackspace Technology today. We are excited to present to you our latest insights on managing and optimizing cloud operations. As we all know, the journey to the cloud can be both exhilarating and challenging. So today we'll be discussing how to navigate these challenges effectively and leverage the cloud to drive innovation and operational efficiency. So let's dive in and explore how we can transform cloud chaos into a competitive edge. And I'll kick it over to Rajan and Mike Lindbert for introductions.
Thank you, Olivia. So my name is Rajan. I'm in Rackspace for now over 15 years. I work in our products division, building services and platform for our customers, variety of experience. I've worked on different cloud providers, different roles. And I'm excited to bring to you how Rackspace manages services in the cloud. Mike, over to you.
Great. Thanks, Sri. So my name is Mike Lindbert, and I lead the public cloud product organization here at Rackspace. I've been with Rackspace just over 7 years, working in product, technology, and solution space, though, for over 20. So today, Sri and I are going to be talking about cloud operations, really in today's complex and chaotic environments. This is a topic that is consistently on our radar as we help thousands of customers with this every single day. For anyone not familiar with Rackspace, we're a leading hybrid cloud and AI solutions company supporting a global customer base across 120 countries. Cloud operations really is in our DNA. This is something that we've been doing for over 25 years. So let's dive right in with the common problem we see in the market, and which is simply put that technology leaders like CIOs, CPOs, CDOs are all pushed to innovate, but many times they're inhibited by legacy cloud architectures. We know that close to half of organizations have essentially done a lift and shift to the cloud, which really is no surprise, is really the most non-optimal way of migrating, and essentially forces organizations into data center-like operations and really limits access to advanced cloud capabilities. But then at the same time, there's this immense pressure to leverage all the new emerging technologies from the cloud providers, such as AI. And so organizations really want to be able to react faster to changing market conditions while also reducing IT spend. And so these are really two opposing forces, right? Where you're trying to operate these legacy workloads in the cloud while still achieving innovation and cost goals. So why is it so difficult for organizations to really untether themselves from the anchor that is legacy cloud architectures while also operating their businesses? And one of the primary obstacles is the lack of talent and expertise. We see that transitioning to modern cloud environments really requires specialized skills and knowledge, which are often scarce. So some on-prem management skills like operating systems, firewalls, DBAs do translate well into the cloud. However, new core skills are also needed across new dimensions. For example, managing EC2 or GCE is very different from managing EKS or Cloud Run. And organizations frequently struggle to find and retain the right talent needed to manage these complex systems. And that really brings us to the complexity of legacy systems and technical debt. Many organizations are burdened with outdated infrastructure and software, which creates significant technical debt. And this complexity makes it very challenging to implement new innovations and hinders the overall transformation process. This includes attempts to integrate modernized applications within legacy systems. We see that seamless integration is really crucial for maintaining business continuity, but it's often a complex and resource-intensive process, and this integration challenge can delay projects and increase costs overall. And so on the topic of costs, budget constraints and cost management are always top of mind. Organizations really need to carefully manage their budgets while investing in new technologies. Managing cloud spend is completely different from on-prem and can change at a rapid rate. Infrastructure is provisioned with the click of a button, and often there's choice overload, which leads to mistakes. And so new methods and new processes are really needed in the modern cloud world. Next, we have the issue of managing the problem of the day versus strategic organizational changes. IT teams are often caught up in addressing immediate operational issues leaving little time for strategic planning and long-term improvements. And this reactive approach can stall transformation efforts. Lastly, operating in a multi-cloud environment, that adds another layer of complexity. You have different cloud platforms that have their own unique features, tools, management protocols, and navigating these differences and ensuring interoperability can be a significant challenge for any organization. And so, in summary, really efficiently operating cloud environments while transforming your cloud architecture involves overcoming lack of expertise, managing legacy complexities, integrating new and old systems while all controlling your budgets, and then balancing sort of the immediate needs of strategic goals while mastering multi-cloud operations. So then how do we address these issues? What does successful modern cloud operations look like today? And so in our mind, there's really 4 key components to it, starting with platform expertise. You either need in-house or outsourced resources that understand cloud-native designs and architecture. They need to know how to best leverage automation and orchestration to reduce manual burden, have proven abilities to drive scalability and performance optimization. And then finally, you need some kind of partnership with the cloud vendor to ensure that any platform issues can be addressed rapidly. Then you need tested and proven operational practices and processes. This encompasses key areas such as resilience, compliance, operational adaptability, and knowledge management. The third component is a strategy for overall environment management and monitoring. And here we would think about concepts like a centralized monitoring plane, incident response, change management, as well as FinOps. And then the last component is around continuous improvement. Now, all 4 of these are important, but this one is really the most critical for organizations that are struggling after a lift and shift to the cloud. Here's where you drive the adoption of cloud native services, really in order to start taking advantage of emerging cloud technologies. And this is what ultimately drives the most cost savings while also gaining improved agility and flexibility at the same time for organizations. So let's spend a few moments on each of these foundational components and talk about how we approach it at Rackspace, starting with platform expertise. One of the advantages we bring to the table is our strategic relationships with the hyperscalers. And one of the resulting benefits is access to funding and training via innovation labs and certification programs. We've also built what we call tribes of technical rackers aligned to specific technologies that help breed knowledge sharing and mentorship. And then finally, we have an internal cloud center of excellence to build and manage reusable assets that help us really expand our extensive library of automation and IP. And now our approach really drives 3 main outcomes for our customers. First, they're able to gain valuable insights based on our experience across multiple use cases that really inform strategic decision-making. Second, our proactive guidance approach leads to well-architected environments much earlier in the lifecycle of cloud adoption. And third, we can accelerate the adoption of new cloud technologies, given we'll be the first ones trained using these technologies. From an operations process perspective, this is really where our 25 years of managing cloud environments comes to light. We've onboarded so many environments that we've optimized specific processes aimed at allowing us to best manage maturity and stability. Once we're in operations, then we layer on service management that's rooted in ITIL best practices, where we work with our customers to agree on the right KPIs so that they can really meet their own business objectives. We then establish a governance framework with reporting and audit. And then finally, we strive to make cost management a very distinct and prioritized service activity. And so what this really means for our customers now is that they benefit from lower risks and an environment that's efficiently operated. We can go beyond the problem of the day and achieve more meaningful outcomes. Of course, we continually optimize for cost as it's a default motion of our delivery. And finally, we're able to achieve greater alignment between IT operations and business objectives through SLAs like availability. Now I'm actually gonna hand things over to Sri to discuss how do we think about availability and how do we manage to it.
Thank you, Mike. So I'm going to jump into a unique SLA that we offer. As a typical service provider, we do all the usual stuff, right? We have our response SLAs. We can provide SLAs around compliance, reporting, all that stuff. But we also address availability in a unique way with something called the platform design guarantee. It's complex in the cloud environment where often application is owned by a set of developers. We have the cloud infrastructure, which it brings its own little nuances to it. And then, of course, as a service provider, there's also an element of how do you manage and respond to those things. So we like to break that down into two groups, right? First is the cloud engineering-led expertise. Now, this helps sort of reduce your single points of failure, both from an application architecture standpoint and also from the cloud services standpoint. We also then have to make sure that your requirements, let's say you have 4 nines, matches the guarantees of the cloud vendor. So you can't really run it on a service that's only providing, say, 2 nines and a 5. You also have to account for third-party dependencies. Often customers have complex applications that talk to external identity providers, say like an Okta. They may have a CDN in front of it. All that sort of needs to be accounted for when we look at the overall application and cloud services design. So our engineering expertise focuses on getting that right. And as part of that, we make sure that the documentation for recovery, the understanding of how the application works in different scenarios is captured. Then the next element of achieving that sort of outcome for SLAs is to respond to cloud events. Now, this is done through a cloud operations runbook and process and execution. So during onboarding, we'll make sure that the availability testing is completed. So if you have planned for, say, an instance failover or a region failover or an availability zone failover, we'll make sure that it actually works in practice. It's not just written down on paper. Then you have to make sure that it's monitoring compliant in a way that you understand when something goes wrong, you quickly identify the root cause for that. And then it's about structured response to these events. So following that runbook to the point where if you have 15 minutes to resolve an issue, you spend 5 minutes running some scripts to do certain calculations and checks, maybe then you escalate, and then maybe you trigger an application rollback procedure. Or you may trigger a procedure for moving the application from, say, one availability zone to the other. What this eventually allows us, and then you as a customer, is to say, okay, I can guarantee some kind of SLA to my business or my eventual customer, and I can get a great degree of assurance to say that's possible, right? Both from a design and architecture standpoint, and also from an operational standpoint. Now, how do you achieve some of that SLAs, and also how do you generally do the overall management of an application that operates in that? So where we approach, of course, is we have extensive service knowledge. We've been in this industry for now over 20 years. We've monitored all kinds of permutations and combination of services, application, and architectures. We also have good understanding of principles of SRE, so we focus on sort of the key signals, right? Latency, traffic, errors, and saturation, making sure that the right things are monitored in the right way. And then, of course, as I'll cover this in the later slides, we integrate this with a combination of automated resolution and response, runbooks that humans can follow, and then a planning for major event as well. As an end user, what you get effectively from this is achievable SLAs, improved resolution time, noise reduction, because often with the monitoring environment, the toil of alerts that mean nothing is a problem, and we make sure that that's reduced. And eventually, this is about lowering your operational costs, right? It's not about closing the same alert every day. It's about improving it and also trying to remove the human from the loop where possible. All said, that means as a customer, you have better uptime, which means you have better customer experience, which means you have a better competitive edge. Now let's keep double clicking onto this. So let's talk about how observability and service management works from a Rackspace standpoint. We bring a wide variety of IP into different aspects of it. And I'll go through this in more details in the coming slide. But at a very high level, cloud infrastructure comes in many forms. You may have the modern way where it's an automated pipeline. You may have UI-based interfaces as well. Our IP then integrates with that in a very smart way, then feeds some of that into our observability platform to get the right dashboards, the analytics in it. And then when we receive alerts and events from it, we again enhance it with our own IP, pushing it back to a service management, and finally to an operations team that manages all that. So let's pick each box separately. So at its core is the Rackspace management platform. You can think of this as a cloud management platform. This is where all the intelligence lies. This has smart integration to the various cloud providers. It has integration into observability tools like Datadog. It also has a whole bunch of automation that we have written ourselves to make all this work properly. So let's look at from a use case of two different cloud infrastructure types, right? Let's start with sort of the traditional one. This is where maybe you've migrated into the cloud, or you have sort of evolved over time into that, right? And you may not have all the automations in place, but of course, from a monitoring and availability standpoint, you still need the same set of outcomes. So in that case, the platform provides a layer where you can do observability tagging, whether it's using the cloud provider's native tagging systems or something in the observability platform itself. We also automate agent installation. That way you can discover all the, say, virtual machines or Kubernetes clusters and install it. And then we also have a variety of discovery tools to look at different aspects of it, right? Understanding where your storage is, for example, database instances. That way you get automated visibility into what's running. On the other end of the spectrum, if you have a modern implementation where you're already provisioning this through cloud infrastructure, pipelines, Terraform, in that case, the platform offers Terraform libraries where we can just add on to you as a module, right? You continue provisioning the way you do, you just take our modules and integrate that with it. And then we also leverage cloud native services in that case. For example, if you're on AWS, the best way to do agent installation is through something like SSM. And so we make sure that we have those instrumentations available as well. And then we also have some cases where customers may have a separate team where the team doesn't want any interference from us. In that case, we can almost let that team continue doing their own pipelines, and then we do sort of out-of-band instrumentation to do that. Of course, all this, the platform gathers, and then it talks to sort of the multi-cloud observability pane to create your standard monitors, create the SLO, the SLA configuration that is needed for the application, create the various dashboards and analytics that are needed to manage it. So all in all, the platform sits across these different models of infrastructure and then builds the common observability layer for the outcomes. I'm just going to walk through a few graphs and a few dashboards, not specifically what the graphs itself, but the outcomes that they go after, right? In this example, we're talking about sort of a single pane for many use cases. This is a collection of all things like metrics, logs, and traces, and it's really targeted at a wide range of stakeholders. Each group, a developer, an IT ops, or a business user, may care about different aspects of it. But this could be sort of your starting point after which you drill down to specific focus areas that you have. If you're from a business standpoint, maybe you're more interested in SLAs and where things are, then we help build sort of an SLO dashboard, which understands different aspects of the application. If you're a technical developer or even an operations guy, you want to understand how the sort of subcomponents of your service. Let's say your overall application is broken down into an API layer, a service catalog, something that does payment. Maybe there is an e-commerce side. And all of these are sort of modular components of services inside, maybe even written in different programming languages and different architectures. They could all be represented into a dashboard as well. And then you can sort of measure similar sort of metrics for all of them. And then, of course, use that to monitor and respond. And which is where the next bit comes, right? Eventually, after all this configuration happens, your monitoring tool is going to give you a whole bunch of alerts. You'll have events, you'll have reports. And again, the management platform that we have at Rackspace comes in between that, right? It takes all of that and then again makes smart decisions across two facets. The first bit is around service management and ticketing. So this is where, for our own systems and tools, we can create tickets. We can also integrate with customers' ITSM tooling if they have one. We can help build some of the SLA reporting that is needed that feeds into sort of upstream reports, for example, a monthly review and things like that. We also help build incident runbooks that so the customers can co-author with us, so that way your IT team and developers have visibility into what Rackspace does from a human perspective and contribute to that. Then when it comes to cloud operations, a lot of this is about understanding the alert and then doing a variety of things. Starting with automated resolution. One of the most common resolutions that we can do is, hey, disk space is full, or in a database, in an instance. Often you have a common set of steps that you can do. You can compress logs, you can rotate query logs, things like that. So we can take those actions, of course, with customers' approval in many cases. We also integrate this into sort of AI operation models, either with observability tool or other facets of Rackspace, where you can correlate this using patterns that you didn't know exist before, and then also feed that into the operation side. And then last, but also equally important, a couple of areas. One is correlation in terms of understanding, hey, when this alert happened, what other similar things happen around the same time, which allows you to combine these into one incident. Maybe an AWS region is having problem, or a Google availability zone is having issues. This helps sort of correlate all of that. That way you understand the problem very quickly. And lastly, enriching alerts with all kinds of other information. So if a customer gives us access to the deployment pipeline, where they have access to that GitHub to understand what changes are happening, we can use that. We can also look at the cloud provider infrastructure to say who last logged into this AWS account or Azure subscription. Take all of that and enrich the alert to say, hey, this alert happened at 10 a.m. In the last 30 minutes, these are the things that happen. Those are very, very useful to cloud operations because often any problem is closely correlated to some change that happened very near that. And so all of that gets fed into sort of a cloud operations automation bucket, if you will, to do all kinds of improvements to the way humans need to deal with it. Of course, you can't take humans out of the equation completely. Eventually, after all the automation is done, all the correlation is done, the resolution is done, you still need expertise who understand the cloud providers very well and then can do further things. For example, root cause analysis to make sure the alerts doesn't happen again. Fix problems and then feed back to the automation to say, hey, it'd be nice if you had done these two things as well. All of that then goes back to the human expertise, and they sort of help continue that life cycle. And again, few views to talk through these things, right? So this is a service mapping from a holistic perspective. So remember the slide where I talked about sort of the service component broken down from a technical perspective. This gives you a visualization of that. This tells you that, hey, these are all the applications, and you can start correlating the red boxes to the ones that are experiencing some kind of event or alert. And you may be able to quickly tell from this that, hey, all these boxes are actually talking to a database instance. So chances are that's a database instance that's the problem. So this aids in troubleshooting. It's also something customers can access themselves. So it also helps their developer environments look at these things and then optimize as well. The other quick snapshot I would like to share is I talked about us doing correlation and enrichment. And this is a small snapshot of a vast library of things that we do. For almost all possible alerts on AWS and Azure that are common in the space, we have some form of enrichment, some form of remediation, some form of diagnostic link that we have built for internal use cases. So this allows us to sort of take all these alerts and apply some intelligence to almost all of them. And what that leads to is effectively what we call sort of a labor minus operations, right? It's not about closing the same alert every single day. It's about making improvements. And we measure that by sort of understanding how many hours did we save with these automations. So all these automation runs in response to a ticket being created. And then we track how these automations save time, right? Whether it's 5 minutes saved per human or half an hour, we collect all of that. And then we use that as a metrics for improvement. I just want to sum up all the slides so far I've been talking about, right? So if you look at all the stuff from observability to service management, all leads to the outcomes that I talked about before, right? You get response that is achievable from an SLA standpoint. You can outpace your competition by doing all that. And of course, all in all, reducing the cost of operations as well. We've been talking primarily about sort of the operation world, right? This is where you're running the cloud, your day-to-day operations, you manage your SLAs and SLOs. You still focus on improvement through all the automation activities that I talked about, but you also have to look about the transformation angle now. And this is more long running, right? You're talking now multi-week, maybe months in terms of a project timeline. This is where you optimize the cloud. You look at more advanced optimization that you go beyond operations. You also look at the next stage of the application lifecycle and where it needs to go. And here we help with sort of a continuous improvement model. We understand the cloud native transformation space quite well, and we understand how it can reduce the technical debt, but at the right pace for the business. You don't have to just adopt Kubernetes because it's just cool. You have to make sure that also aligns to something that works for the business. We can also help increase levels of automation through existing patterns on CI/CD, IAC, our libraries, and all the stuff that we have. We also work very closely with the IT team or the DevOps team on the customer side, and this helps rub off some of that knowledge as well. And then we sort of do that in sort of a do-with approach, right, where we use agile methodology, layer on top with the customers, and then work. From an outcome standpoint, at the end of the day, this is about increased cloud maturity, getting the better ROI with the investment, whether it's adopting new services or improving existing ones, all about that. Better understanding of the next stage, and I'll talk a little bit more about how we approach this as well. Some of this automation actually reduces security risks, right? Because now you have better pipeline, you're shifting left some of your problems, and you understand the security implications at a much earlier stage. And if you're in a compliant and regulated industry, you can introduce automated testing from a security lens as well. And then the do with approach that we have effectively means that we are an extension of your team. We know your environment very well, we know your teams very well, we know your objectives very well, and then we can work very, very closely with that. So how do we achieve the continuous improvement? Is through a cloud maturity model. This is a multi-stage improvement process. That's something that we've built as part of our IP. It includes a long list of checks, reporting, dashboards for different stakeholders. But the general idea with this is to take you through the different stages. Depending on how you ended up in the cloud, you may be in any of these stages. Typically with customers who are migrated, you're sort of in the early stages of this. If you built yourself on the cloud, you're probably in stage 2 and 3 of foundational understanding. You're starting to reap some benefits and you're starting to look. What this helps customers do is put a stake and saying, hey, this is where I am and this is where I want to be. And then it sort of helps plan the next few sprints, if you will, or how do you slowly get to that? Because often these are multi-stage projects where they might take months, but you can show value by slowly, incrementally doing that and then achieving those things. And so effectively, this is all about working from, say, you're building a data center in the cloud to being extremely cloud fluent, where you're using innovative use of new technologies, using automation as much as possible. You also have a lot of in-house SMEs to work with as well. With that, let me hand it over back to Mike, who's going to talk about a customer of ours. Over to you, Mike.
Thanks, Sri. So before we wrap things up, I wanted to briefly discuss a recent customer example that really highlights the application of what we've been talking about here today with modern cloud operations. And so in this case, our customer is a fairly large broadband ISP, and they were going through a divestiture process. They had a very tech stack as part of their former parent company, included Google Cloud, Azure, Citrix, and sort of a host of different security tools. And their managed service provider at the time was not meeting their SLAs. And as a result, our customer was really spending significant amounts of their time managing this MSP, fixing the issues within the cloud environment, instead of focusing on their core business. And in fact, they were at a high risk of not meeting some key product launch milestones that were really crucial for the business. And so we engaged, did an assessment of their environment and looked at the type of support that was required. They made the decision to switch to Rackspace. We executed a transition in just under 2 months, taking over complete management of the environment. And so when we took it over, it had about 0% automation. And we increased that to near 70% today with a goal to get to 90% in the near term. And so as a result, we were really able to drive down their cloud operations costs by 20% through that mix of automation, as well as the proven processes and techniques that we've talked about here today. And so as a result of this partnership, the customers are actually able to meet their deadlines because they can now be hands-off from the cloud operations part of the business and really then focus all their energy on the core business activities. So in closing, I really want to thank everybody for your time today. And I hope that Sri and I were really able to shed at least a little bit of light in a short amount of time on how to properly manage through the chaos of cloud. And if you're ever interested in learning more about how Rackspace can partner with you on that journey, we would really love to talk with you. Our goal is to help you achieve your business objectives while reducing your operational costs through this proven cloud services approach. So thank you again and look forward to connecting.
Thank you so much, Mike and Sri, for all this great information. For any follow-up questions that you all have, we are offering a complimentary assessment so that we can help you and your organization discover your path to cloud excellence. So scan the QR code here and we can get you connected to a team of experts and chat about your specific environments. Thank you all again for your time, and we look forward to speaking with you soon.